Hello students, I am Ma'am Zenny. Welcome to our online class. I am very happy to meet you all. Let us start our mathematics video tutorial.
Our lesson for today is about square number and square root. Our objectives for this lesson are: define square number and square root. Identify if a number is a perfect square or not. Determine the square root of a number. Lesson 1. Square number. What is a square number? A square number or perfect square is a number obtained when we square a number. Squaring a number means raising a number to the power of 2. This example read as 5 raised to the power of 2, or 5 to the second power, or 5 squared. 5 is the base. The base is the number or variable that is being multiplied repeatedly. 2 is the exponent. Exponent, the value that tells how many times to multiply the base by itself. Example, we have 1 squared. 1 squared is in the exponent form. 1 is the base and 2 is the exponent. This means we are going to multiply 1 by itself 2 times. So in expanded form, this is equal to 1 times 1. 1 times 1 is equal to 1. The same with 2 squared. Multiply 2 by itself 2 times. This is equal to 2 times 2. 2 times 2 is equal to 4. Next example is 3 squared. The common mistake here is sometimes they multiply 3 times 2, which is wrong. Remember, exponent tells how many times to multiply the base by itself. In our example, 3 squared, the base is 3, the exponent is 2. So meaning, we are going to multiply 3 and itself 2 times. So this is equal to 3 times 3. 3 times 3 is equal to 9. The same with 4 squared. 4 squared in expanded form, this is equal to 4 times 4. 4 times 4 is equal to 16. 5 squared in expanded form, that is equal to 5 times 5. 5 times 5 is equal to 25. Take a look with our products. 1, 4, 9, 16, and 25. These are the answer when we multiply a number to itself. 25 is the product when we multiply 5 by itself. These products are called square number or perfect square. A square number or perfect square is a number obtained when we square a number or when we multiply a number by itself 2 times. Next example, 6 squared. 6 squared is equal to 6 times 6. 6 times 6 is equal to 36. 7 squared is equal to 7 times 7. 7 times 7 is equal to 49. 8 squared is equal to 8 times 8. 8 times 8 is equal to 64. 9 squared is equal to 9 times 9. 9 times 9 is equal to 81. 10 squared is equal to 10 times 10. 10 times 10 is equal to 100. These products are square numbers or perfect square. We can also continue from 11 squared to 15 squared. So the products are square numbers or perfect squares. Same with 16 squared to 20 squared. The products are square numbers or perfect squares. Let us have this illustration. In getting the area of a square, square has 4 equal sides. We are multiplying side by its side, or that is equal to s times s, or s squared. Example, if we have a square whose measure is 2 centimeter by 2 centimeter. So we are going to multiply 2 centimeter times 2 centimeter. So that is equal to 2 centimeter squared. So 2 centimeter squared is equal to 4 centimeter squared. So the area of a square is 2 centimeter squared. Another example, if we have here a square, let's count how many units. 1, 2, 3. So this is 3. 1, 2, 3. So 3 by 3. So let us multiply. 3 times 3 is equal to 3 squared. 3 squared is equal to 9. Next example. This is 4 by 4. So let us multiply. 4 times 4 is equal to 4 squared. 4 squared is equal to 16. Next, this is 1, 2, 3, 4, 5. 5 units by 1, 2, 3, 4, 5 by 5. So that is equal to 5 times 5 is equal to 5 squared. 5 squared is equal to 25. So let's count how many units inside the square. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25 units inside square. Next, this is 6 by 6. So let us multiply 6 times 6 is equal to 6 squared. 6 squared is equal to 36. Next example, we have 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7 by 4. So what have you noticed? What figure is this? Is this a square? No, this is a rectangle. Rectangle is a quadrilateral with opposite sides are congruent. They have the same length and the same width. In getting the area of a rectangle, we are going to multiply the width by its length. So 4 times 7. 4 times 7 is equal to 28. Next, this is 1, 2, 3, 4, 5. 5 by 1, 2, 3, 4, 5, 6, 7. 5 by 7, let us multiply. 5 times 7 is equal to 35. Look at the figures. Numbers 4, 9, 16, 25, and 36 form a perfect square, while the numbers 28 and 35 does not form a perfect square. One property of square number or perfect square is it can be represented by a square array. Square number or perfect square can be represented by arranging objects in a square. Thus, 4, 9, 16, 25, and 36 are square numbers or perfect square, while 28 and 35 are not square numbers or not a perfect square. Our next lesson is about square root. What is a square root? Square root of a number is the number times itself that equals to the given number. Taking the square root is figuring out what number multiplied by itself is equal to the given number. Square root is the opposite of squaring a number. Let us have this illustration. Inverse operations are pairs of math operations that undo each other. For example, addition and subtraction. You can undo addition by doing subtraction. You can undo subtraction by doing addition. So addition and subtraction are inverse operations. Likewise, you can undo multiplication by doing division. you can undo division by doing multiplication. So multiplication and division are inverse operations. Exponents have inverse operations also. There are operations that can undo them, and those operations are called roots. To see roots and exponents work together to undo each other, let us look the simple exponent 5 squared. 5 squared is equal to 25. Doing this exponent going from 5 squared to 25. If we want to undo that with a root operation, start with 25 going back to 5, which is being raised to the second power. Doing the root operation is going to give you the base as an answer, which is 5. Remember, 5 is the base and 2 is the exponent. The words base and root have a similar meaning, especially if you think of a tree. The root is also the base of a tree. And that can help you remember how root operations work. With the root operation, you start with the answer of an exponent, which is 25, and try to figure out what is the base of the original exponent. The base of the original exponent is 5. That is getting the square root. Thus, square root of 25 is equal to 5. Exponent and square root are inverse operations. Examples: square root of 4. When we did the root operation, we ask, what number or base could we multiply to itself 2 times to get 4? The answer is 2. Since 2 squared is equal to 2 times 2. 2 times 2 is equal to 4. 4 is a square number, and the square root of 4 is 2. Thus, square root of 4 is equal to 2. Next, square root of 16. What number multiplied by itself 2 times will give us 16? The answer is 4, since 4 squared is equal to 16. Thus, square root of 16 is equal to 4. Next, square root of 36. What number multiplied by itself 2 times will give us 36? The answer is 6, since 6 squared is equal to 36. Thus, square root of 36 is equal to 6. Identify if a number is a perfect square or not a perfect square. Number 1, 9. 9 is a perfect square. Number 2, 14. 14 is not a perfect square. Number 3, 27. 27 is not a perfect square. Number 4, 121. 121 is a perfect square. Number 5, 170. 170 is not a perfect square. Find the square root of the following. Square root of 9 is equal to 3. Square root of 49 is equal to 7. Square root of 81 is equal to 9. Square root of 64 is equal to 8. Square root of 144 is equal to 12. Square root of 225 is equal to 15. Square number or perfect square. These are the square numbers or perfect squares from 1 to 400. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, 324, 361, and 400. Square root chart. Square root of 1 is equal to 1. Square root of 4 is equal to 2. Square root of 9 is equal to 3. Square root of 16 is equal to 4. Square root of 25 is equal to 5. Square root of 36 is equal to 6. Square root of 49 is equal to 7. Square root of 64 is equal to 8. Square root of 81 is equal to 9. Square root of 100 is equal to 10. We have also another set of square root chart. Remember, square numbers or perfect squares have two square roots, one positive and one negative. Example, what are the square roots of 25? The square roots of 25 are positive 5 and negative 5. Since positive 5 times positive 5 is equal to positive 25. Negative 5 times negative 5 is equal to positive 25. Thus, the square roots of 25 are positive 5 and negative 5. Another example, what are the square roots of 49? The square roots of 49 are positive 7 and negative 7. Since Positive 7 times positive 7 is equal to positive 49. Negative 7 times negative 7 is equal to positive 49. Thus, the square roots of 49 are positive 7 and negative 7.
That's all for today. Once again, this is Mom Zenny saying mathematics is not about numbers, equations, computations, or algorithms. It is about understanding. This quote is from William Paul Thurston. Please don't forget to like and subscribe para updated ka sa lessons and video tutorials natin. You can also share this video tutorial with your friends. See you in our next lesson. Bye!